everyone. This is the second lecture of our example number 3, which is the design of two-way slab. So students, in the last lecture, we are discussing about what is the difference between one-way slab and two-way slab. And after that, we are completing our step number 1, which is the effective depth calculation. But students, there is one mistake in the question. So the question in which the live load is taken as 4 meter, but in the last lecture there is considered as taken live load is equal to 5 kilonewton per meter square. So from now onwards, in this example, we have to completed all the steps having the live load is equal to 4 kilonewton per meter square. Okay. So in the last lecture, we have to completed our step number 1, in which we have to find out our value of small d. So the equation of the find out the small d is L by D is equal to ratio into modification factor, and there is some major difference between to find out the ratio, because there is one important notes which is given on page number 39, that if your shorter span is less than 3.5 meter and your live load is up to 3.0 kilonewton per meter square, then your value of ratio is 35 or 40 accordingly to types of slab. So in the last lecture we have to completed our step number 1. So in today's session we will start our example from step number 2. So our step number 2 is to find out effective span. So we have to move to page number 34 and 35. So all the students are moved to page number 34, in which there is clause number 22.2 named as effective span. So as per clause number 22.2, the subtopic is A, but A is for simply supported slab or beam. But in this example, we have to use continuous slab. So for continuous slab, we have to first of all check one condition. So you can see that in the case of continuous beam or slab, if the width of support, and you all know that your slab is resting on beam, so beam is your support of slab. So in the question it is clearly mentioned that your width of support is 300 mm, but whenever there is no any clarification, then you have to assume as 230 mm or 300 mm, whatever you have to required or whatever you have to thinking about it. Okay. So in this example, we have to use width of support is equal to 300 mm. Now your clear span, okay, you can see that is less than 1 by 12 of clear span. So 1 by 12 is constant. So first of all, we have to find out clear span. Now, what is the meaning of clear span? So students, your clear span is inside to inside distance. Okay. So you have to find out clear span with the help of this figure, because in the system which is given in the question, in the system all the dimension is center to center dimension. Okay. So students, your 3 meter is your center to center dimension. You can see that this is 3 meter is equal to 3000 mm, and your slab is resting on beam. So the width of beam is 300 mm. Now if you have to find out clear span which is inside to inside distance, then you have to deduct the half value of width from both the side. It means if you have to deduct half the value, it means half plus half. It means you have to deduct one full value of width of support from the center to center distance. So your clear span is equal to 3000 minus 300, which is equal to 2700 mm. Okay, now your clear span divided by 12 is equal to 225 mm. So first of all, we have to check this condition is satisfied or not. Then your width of support, which is 300 mm, less than 1 by 12 of clear span, which is 225 mm. So students, 300 mm less than 2 to 500 mm. 2 to 5 mm. This condition is satisfied or not? Obviously not satisfied. Then you can see that if this condition is not satisfied, then the effective span shall be taken as under. So on page number 35 there is other three conditions, but in this example we have to satisfy for condition number 1, because you can see that for end span, so we have to design for slab S1. So your slab S1 is your end span. Okay, because your slab is discontinue over here and discontinue over here. So you can see that for end span with one end is fixed. It means your left support is fixed and the other is continue, and your right support is continue, because in the last lecture you can see that your reinforcement in x direction is discontinue on this edge and continue on this edge. Okay. For that case, your effective span shall be clear span between support. It means your effective span is equal to clear span. So students, your value of LEX is equal to 2700 mm, and this is the calculation of shorter span, and similar calculation for longer span. Then the value of effective span in Y direction is 4700 mm. Okay, so students, this is the end of your step number 2, which is to find out effective span. Now we are moving further to our step number 3, which is a load calculation. So you all know that in any slab there is two types of major load. First one is dead load and second one is live load. And in dead load there is two load. First one is sulfate of slab and second one is floor finish. And you all know that it is already discussed that we have to design all the component for UDL only, uniformly distributed load only. There is no any point load is considered if there is no any special clarification then. Okay. So whenever you have to not given the value of floor finish, then it is assumed as 1 kilonewton per meter square. Now our first load in dead load is sulfate of slab. So the equation is rho into B into D. Now the density of concrete is given as 25. B is equal to 1 because we have to calculate all the loads per meter length, and your value of capital D. Capital D means thickness of slab, which is 125 mm. So we have to convert mm to meter. So it is 0.125. So students, after putting all this value, we will get our answer of sulfate of slab is 3.125 kilonewton per meter. Okay, so this is our first dead load. Our second dead load is floor finish. Now, your floor finish is given as 1 kilonewton per meter square, but we have to find out all the forces per meter length. So your 1 into 1, this one is for per meter length. So your answer of floor finish is 1 kilonewton per meter, and your live load is given in the question as 4 kilonewton per meter square. Now whenever we have to convert kilonewton per meter square to kilonewton per meter, then we have to convert it with the multiplication of some length, and that length is to per meter length. So your live load is equal to 4 into 1. It is 4 kilonewton per meter. So students, in any slab, there is a summation of dead load plus live load. So our total load is the summation of all the three forces, which is 3.125 plus 1 plus 4, which is equal to 8.125 kilonewton per meter. Okay, but this total load is unfactored load, and we have to design any structural component for factored load. So we have to convert unfactored load from factor load with the multiplication of some factor of safety, and that factor of safety is 1.5. Okay, so students, your factor load is 12.20 kilonewton per. So this is the end of our step number 3, which is the calculation of load. Now we are moving further to our step number 4, which is to find out moment calculation. So students, in the two-way slab, whenever we have to find out bending moment, first of all we have to find out bending moment coefficient. De- Depend on the types of slab, because it is already discussed in the last lecture that in the two-way slab there is 9 different cases. Okay, so for slab number S1, which case is available and which case is possible in this example? So for that case, we have to find out first of all some bending moment coefficient, and after that we have to find out bending moments. Okay, so you all the students are moved to page number 91 of IS 456 2000. So this is the page number 91 of IS 456 2000. So students, as per this figure and this system, our slab S1 is this. Okay, and you all know that in two-way slab, your main steel is on both the direction. So you can see that whenever we have to provide it our main steel in this direction, your main steel is discontinue on this direction, but our main steel is continuous on this direction. Okay, similarly, whenever we have to provide it our main steel in this direction, it means in vertical direction, our main steel is discontinue over these edges, but our main steel is continue over these edges. It means your main steel is discontinue over two edges, which is these two edges. Okay. So which condition is preferable? So you can see that your condition number 1, case number 1 is for interior panel. Your case number 2 is one short edge continuous, or it is also called as one short edge discontinuous. Your condition number 3 is one long edge continuous or discontinuous. But in this example, our reinforcement is two edge discontinuous. For that case, our case number 4, two adjacent edges discontinuous. It means two nearer faces is discontinuous. So you can see that in this system our slab number S1, in which your reinforcement is discontinuous over these faces and discontinuous over these cases. So for this example we have to refer our case number 4. Okay, so for case number 4, there is 4 bending moment coefficients. First one is, this is alpha x, and for alpha x there is two values. First one is negative moment coefficient and second one is positive moment coefficient. And similarly, our last column, which is alpha y, so there is two values for alpha y also. For alpha y there is two value, which is alpha y negative and alpha y positive. But student, for whenever we have to find out alpha x, the value of alpha x coefficient is depend upon some ratio, and that ratio is LEY divided by LEX. In the IS codal provision, there is written as Ly by Lx, but there is no Ly by Lx. It is Ley upon Lex. Okay. So the value of alpha x coefficient is depend on this coefficient, but your coefficient of alpha y is depend on nothing. Okay. So your ratio, your coefficient of alpha y in this example is 0.047, which is negative coefficient. So you can see that your alpha y negative is 0.047 and your alpha y positive coefficient is 0.035. Okay, now we are moving further for the alpha x coefficient. So for alpha x, first of all we have to find out Ley by Lex ratio. So that Ley by Lex is 4700, which is calculated in step number 2, and our Lex, which is 2700, which is calculated in step number 2. So this ratio is 1.74. Now you can see that if your Ly by Lx ratio is 1, 1.1, 1.2, 1.3, 1.4, 1.5 and 1.75. Now your Ley by Lx ratio is 1.74, which is approximately nearly equal to 1.75. So you can see that for 1.75 your negative coefficient is 0.084 and your positive coefficient is 0.063. So students, this is the calculation of alpha x coefficient and alpha y coefficient. Okay. So this is the for case number 4 only. How for other 8 cases? So for that other cases we are moving further later whenever we have to decide how to design slab S2, S3 and S4. So it is discussed later in this example. So students, after finding out the alpha x negative and positive coefficient, now we have to find out moments. So this moment equation is given just below the table of page number 91. So the equation of mx is equal to alpha x w lx, but there is no lx, it is lex square. Okay, so we have 4 coefficient in which 2 coefficient for mx, sorry, 2 coefficient for alpha x and 2 coefficient of alpha y. So if we have 4 coefficient, then we have 4 moments. So first of all we have find out for mx positive. So over here we have to return for alpha x positive. So what is the value of alpha x positive? It is 0.063. Next is w. So the value of W is 12.20, which is calculated in the last step, and the value of LEX. So students, your value of LEX is equal to 2700 mm, but we have to convert mm to meter by dividing 1000. So 2700 divided by 1000. So we will get our answer 2.7 square. So students, after putting all this value, we will get our answer of mx positive is equal to 5.60 kilonewton into meter, and similar calculation for mx negative. Only change is in the value of alpha x negative coefficient, which is 0.084. But the main difference in mx and my equation is whenever we have to use mx, it is lex square, and whenever we have to use my, you can see that lex over here there is no ley, because all the students are sometimes makes a mistake whenever it is hurry in written. Okay, so your equation of my is equal to alpha y into w into lex square. So students, you can see that whenever we have to find out my positive, the coefficient is for alpha y positive, which is 0.035, W is equal to 20, and LEX, which is 2.7 square. So students, after putting all this value, we will get our answer 3.11 kilonewton into meter. And at last, my negative. So the value is for my negative, it is 4.18 kilonewton into meter. So students, this is the end of today's session, and in the next lecture, if we have four moments, after finding out the moments, which step is to be followed? Moment, then PT, AST, spacing provided and AST provided. These steps is provided and this step is followed for all the four moments. Okay, so in the next lecture we have to find out the reinforcement calculation, and at last we have to find out the edge strip reinforcement. Okay, so students, this is the end of today's session. Thank you.